Okay, today what we're going to do, we're going to try to find the area of a quadrilateral in the coordinate plane. Now, if you take a look at what we have here, they do have the vertices marked, but they do not have this plotted on a coordinate grid to scale. Could you do that on your own? Yes. However, if you look at the bottom vertice, it's -2, -17. You're probably going to run out of room. And the idea here is for you to find out how to get the lengths without actually having to graph it. So the first thing that we need to remember is that when we look at the vertices, we have an x and a y value. We know our x is going to run horizontally, left and right. The y value goes up and down or vertically. And so we need to make sure that we understand that when we're trying to find the values. Now on this particular polygon, none of the sides are running parallel to the y-axis or the x-axis. So now we're going to have to go ahead and draw our own line. And we can go ahead and go from one side of the polygon to the other. And so now, if you take a look, what we actually have is a triangle. We should know how to find the area of a triangle. The area is going to be 1/2 times the base and the height, or we could say the base times the height, and we could divide it by 2. By doing this, we could find the area of the top portion of the polygon, and then we would know that the bottom portion would be congruent or exactly the same, so we could just double it. So our goal is going to be to find this green line, which is going to go from the left to the right, and then we need a line that is going to be the height. The horizontal line will be our base. The height will have to be at our top vertice. We'll have to drop it down so that it would form a 90-degree angle. So here we would have a base and a height. So that is our goal right now, is to find those measures. I'm going to clear this part off. And I'm going to go ahead and delete that. And so our goal is to find the length. And again, we're looking at left to right. So what variable, what number are we looking at here? We're looking, if it's left and right, it's going to be the x value. So I'm going to take a look, and I've got a -8 here, and I've got a 4 here. So now you can ask yourself, if I'm looking at this vertice, how far away is this from the y-axis? And you would say it is 8. And if I take a look on the right side of the y-axis, how far away is the vertice? And we would say 4. So we would have 8 plus 4, and so now the base we would know would be 12. We would add those up. Now our goal would be to find the line from the third vertice that would drop down to the base at a 90-degree angle. So now we have to find out that measure. The only way that you're going to be able to find the measure is to find the measure of one vertice to the other. And because that is running parallel to the y-axis, we know that if we look at our y value, here we have a -3, here we have a 17. If we look at those two values, we need to find out what is in between -3 and -17. And when we say what is in between, we need to find the difference. So if we're finding the difference implies subtraction, so your sign of operation would be subtraction. I'm going to put this in a parenthesis because it's easier to read. It's just more readable. It has nothing to do with order of operations. So if we're looking at -3 and we're going to subtract -17, I'm going to allow you to pop that in your calculator. If you do that, you need to just know that the negative sign is right under the 3, and the subtraction sign is with the other operations on the far right of the calculator. So you would put in -3 minus a -17 in your calculator. So -3 minus -17, and you'll find that the difference is going to be 14. We've done this in class where we look at -3, that's where we're starting out, And we know that if we take away something negative, if we take away negatives, it would be just like adding positives. So we could look at -3 plus 17, and we would then get our sum, because we are adding now, we get a sum of 14. So the distance between this vertice and this vertice would end up being 14. We need just half of that. I'm going to go ahead now and clear this off. We would just need half. So we know from here to here, we had our 8 and our 4, which was 12. We know that the total from here to here was going to be 14, so half of that would be 7. If I want to find the area of this triangle, I would say the base 12 times 7. Okay, we have our base 12 times 7. We would end up with 84. If we just wanted to find the area of the triangle, we would go ahead and cut that in half. We divide that by 2. But because, and that would be 42, but because we're looking for the area of the entire polygon, we know that those triangles would be congruent. We'd leave it at 84, and our answer then would be 84 units squared. And that's it.